In this section, let's understand one of the most important concepts in Python, that is Lambda functions. In this video, we will learn what are Lambda functions and how to use them, map functions along with Lambda function, and how to use filter function and reduce function. Check the description section for more details. Let's begin with the concepts now. First of all, let's understand what are Lambda functions in Python. Till now, we have understood how to create and call a function with the identifier, that is with the name of a function. Python gives a flexibility to create a function without name. They are called anonymous functions or Lambda functions. In Python, anonymous function is a function that is defined without a name. While regular functions are defined using the def keyword, anonymous functions are defined using the lambda keyword. Hence, anonymous functions are also called lambda functions. Now let's understand how to use lambda functions in Python. A lambda function in Python has the following syntax. So lambda functions can have any number of arguments but can have only one expression. Arguments are similar to the parameters that we have created in the function header. The expression is the one which operates on the arguments and returns the result. And the expression is similar to the one which we use to put in the return statement. Lambda functions can have only one expression, whereas def can have more than one expression inside the function. And hence, lambda is applicable for coding simple functions. Lambda functions can be used wherever function objects are required. And lastly, lambda functions are not exactly the same as lambda in functional programming languages, but it is a very powerful concept that's well integrated into Python and is often used in conjunction with typical functional concepts like filter, map, and reduce, which we will discuss in the later part of this lecture. Let's understand lambda function with an example. Let's create a regular function first. Here we have created a function to calculate a cube of a number. Once the function is created, we have to call the function to perform a specific action. Here the function accepts one parameter and calculate the cube of the number, as we can see in this case. The expression which is associated with the return statement basically calculates the cube of a number which is inputted as an argument to the function. As we can see in this case, we are calling a function with the argument value as 3 and we are getting a result which is a cube of that number. Now let's write the same function using lambda expression. This lambda expression have no name. In other words, this particular function has no name. It returns a function object which is assigned to the identifier cube. We can now call it as a normal function. So this will do same as the previous function. Arguments that is mentioned before the colon forms the list of arguments and expression after the colon which will be evaluated on arguments. Once this code is executed, it will return an object. Later, we can pass an argument to the lambda object to evaluate the expression, as we can see here. As we can see in the output, both examples, that is the first example which is written as a regular function and the second function which is a lambda function, have yielded the same result. Let's create one more example to have more insights to lambda functions and understand what are the applications of lambda functions in real time. Here I have created a nested function with def keyword. So this is an example with a nested function where square underscore cube is an outer function and square and cube are the inner function which is created inside square underscore cube function. In the return statement, we are using an expression which basically calls the inner function and returns the list of the square of the number and a cube of a number which is passed as an argument to the outer function. So this function basically accepts one parameter and calculates the square and cube of that number using nested functions and returns the result in the form of a list. Now let's call the function. As we can see in the output, this function have returned the square and cube of a number in the form of a list. Sometimes nested function makes the code more complex. In such situations, lambda functions are useful in replacing nested functions. Let's create the same code by replacing nested function with the lambda expressions. Let's call the function. As we can see in this case, it has produced the same result as before, and the nested functions are replaced with the simple lambda expressions. So lambda expressions basically returns object which can be called later with the argument that we are doing here with the return statement. Since lambda is an expression, we can use them wherever expression can be used. Meaning a lambda expression can be used inside a list, inside a dictionary, or within a function, or in any place where expressions are applicable. As we can see here, lambda functions makes the code looks cleaner and makes the code to be more efficient. So let's create another example for lambda expressions. So here we are created a lambda expressions inside a list. When this particular line of code is executed, a lambda expressions will be evaluated and it returns a lambda object which are placed as an element in a list. This will return the list of lambda objects, and later we can iterate over the objects to perform the task. As we can see here, we are iterating over the lambda objects, and lambda objects will calculate the square and cube of the number and returns the corresponding value. So this is how we can use lambda expressions. So let's understand some of the usage of lambda expressions in Python. We use lambda functions when we require a nameless function for a short period of time. We generally use it as an argument to a higher order function, that is, a function that takes other function as an argument. Most of the times, lambda functions are used along with built-in functions like filter, map, and reduce. So let's understand these higher order functions one after the other. Let's begin with understanding the map function. The map function applies a given function to each item of an iterable. So iterable can be a list, tuple, etc. and returns a list of the results. As I have already mentioned, an iterable can be a list, tuple, and any other data structure which supports iteration. So this is the syntax for map function. As we can see in the syntax, map function accepts two parameters. Function is the first parameter and map passes each item of the iterable, which is a second parameter, to this particular function. So function can be a regular function which is written by using a def keyword, or it can be a lambda expression, where the second parameter, which is a iterable, which is to be mapped to a function. You can pass more than one iterable to the map function. The map function applies a given function to each item of an iterable and returns a list of the result. The returned value from the map is basically a map object, which later can be passed to functions like list to create a list or set to create a set, and so on. So let's understand how map works with an example. Here in this example, the function square will iterate over the iterable and performs the square of the items of the iterable and returns the result. So when we execute the program, as we can see in the output, so list1 is basically a list which is passed to a function square. When the list is passed to a function, so this will iterate over every element of the list, and this particular expression will perform the square of all the elements of the list. As we can see in the output is basically the square of all the elements of the original list. So we can write the same code using the map function like this. The map function in Python takes in a function and a list. The function is called with all the items in the list, and a new list is returned which contains items returned by that function for each item. Here in this function, the map will double all the items in a list. The function is modified to return the square of the number on all the elements of the list. Here in map function, the function square is called with all the items in the list, and a new list is returned which contains items returned by that function for each item as shown in the output. Since map expects a function to be passed in, Lambda functions are commonly used while working with map functions. So what is happening in this function is we need to create a function first, and then that function needs to be used inside a map function. Instead of creating a function and using inside a map function, we can use an anonymous function, that is Lambda functions, inside a map function. Now let's understand how to use Lambda functions with map. So let's create the same previous example with a map and Lambda expressions. In this example, this code will iterate over the item of the list and calculates the square of the item and returns the list of the square of all the items of the list as shown in the output. Lambda functions take in elements from the list and returns the square of the number. Similarly, in this example, this will iterate over the item of the list and calculates the cube of the item and returns the list of the cubes of all the items of the list as shown in the output. As we can see here, this particular map function have returned the square of all the numbers of a original list, whereas in this particular example, this have returned the cube of all the elements of the original list. Till now, we have been passing a single argument to Lambda function. Now let's create a map function which accepts two arguments to Lambda function. Here we have created two lists and we are passing two lists to the Lambda function. Map function will iterate over the lists list1 and list2 and then associates with num1 and num2 respectively. In this example, corresponding items of two lists are added and performs the addition and returns the list as shown in the output. As we can see in the output, corresponding items of the two lists are added and returned. Map function will return the complete list. What if we don't want complete list but required sublist depending on the condition? Then we can use filter function to achieve the same. Let's understand the filter function. So the filter function constructs an iterator from elements of an iterable for which a function returns true. In simple words, the filter function filters the given iterable with the help of a function that tests each element in the iterable to be true or not. So this is the syntax for filter function. The filter function takes maximum of two parameters, where the first parameter is the function, and this is a function that tests if elements of an iterable returns true or false. If it is none, the function defaults to identity function, which returns false if any elements are false. Iterable is a second parameter, that is iterable which is to be filtered. It could be sets, lists, tuples or containers of any iterators. The filter function returns an iterator that passed the function check for each element in the iterable. Let's create a function to understand how filter function works. So the filter function in Python takes in a function and list as arguments. The function is called with all the items in the list and a new list is returned which contains items for which the function evaluates to true. Let's create an example with a filter function to filter out only even numbers from a list. In this case, filter will iterate over the list and checks the number is odd or even, and returns only if the condition is true. Here in this case, it returns true for even number. Hence, we can see in this example, filter function will filter the list for even numbers. What basically it does is, so the lambda function consisting of an expression which basically tests whether a number is odd or even. The filter function takes two arguments where the first argument is a function. In this case, it is a lambda expression. If the lambda expression evaluates to true, then that specific element will be returned. What happens here is, the lambda expression is evaluated for every element of the list 1. So if the number is even, then that particular number will be returned in the output list, else the number will be discarded because that will be evaluated to false. Hence in this case, we get this output where the output elements are even numbers. Let's understand how filter function works without function as an argument. That is, we already know that it accepts two parameters where the first parameter is a function. So in case of filter, it can be a function or it can be none. So now in this example, we will understand how a filter function will be evaluated if the first argument, that is in the place of a function, if we are passing none. Here we have a random list of number, string and boolean in random list. We pass a random list to the filter method with first parameter as none. With filter function as none, the function defaults to identity function and each element in the random list is checked if it's true or not. When we loop through the final filter list, we get the elements which are true, 1 Python, true, and 0. Here 0 is a string because it is placed inside the quotation, will be evaluated to true. As we can see in the output, false and 0 are not returned since they represent boolean false. This is how the filter function works in Python. Now let's understand our last function, that is reduce function. Reduce has been dropped from the core Python while migrating to Python 3. So this is the syntax for reduce function. The function reduce continuously applies the function to the sequence and it returns a single value. From the later versions of Python 3, we must import the reduce function, which is basically present in the functools module. As I have already mentioned, reduce is available with functool module. We have to import first to use the reduce function. Here at first, the first two elements, that is 47 and 11 of sequence, will be applied to lambda function. So in the lambda function, we have written an expression. So what exactly happens here is, the lambda function will check the first number is greater than second number. After evaluation, it will return whichever the number is greater. In this case, in the first iteration, we are passing two elements, that is 47 and 11. Since 47 is greater than 11, it will return 47. So in the next step, the lambda function will be applied on the previous result and the third element of the list. And then it returns whichever is greater, and it will continue like this until just one element is left and return this element as the result of reduce. So for example, as I have already mentioned, initially we pass 47 and 11. Since 47 is greater, so the 47 will be returned. In the next iteration, the 47 and 42 will be passed. In the second iteration also, since 47 is greater than 42, 47 is returned. In the third iteration, 47 and 102 is passed. Since 47 is less than 102, the greater is 102 and hence it returns 102. Like that, it will continuously apply this logic till a single number is returned. Let's create another function to understand a reduce function. Here, range function will generate a sequence from 1 to 100 and calculate the sum of all the numbers of a sequence. Here at first, the first two elements of the sequence will be applied to lambda function and add those two numbers and returns the value. In the next step, lambda function will be applied on the previous result and the third element of the list and returns the sum. And it will continue like this until just one element is left and return this element as the result of reduce. So this is how we can use reduce functions in Python. In this lecture, we have understood how to use lambda expressions and how to use lambda expressions with map function, filter function and a reduce function. That's all for this lecture. Let us know if you have any questions. Thanks for watching. Let's meet in the next video. Thank you.